Dear students, we are facing some technical issue and we'll start in another 10 minutes. Sorry for the inconvenience.
Madam, can you allow me to start the share screen? But not screen share is not happening.
Madam, we can start. Yes. Good afternoon, all of you. Sorry for the late start. Actually, there is some due to some technical issues. I'm unable to start on time. Sorry for it. Yes. Now let us continue with our probability. Last session we were doing probability. Now let us continue with our probability session. Okay. So I think last lecture I have completed up to this one, like what you know, independent event and dependent event.
Yes. Odds in favor for A is equal to 3:2. What is it? Odds in favor for A is equal to 3:2, which is nothing but P of A is first part divided by total. 3 plus 2 is 5, 3 by 5. Same way, odds against. What is odds against is equal to, if odds against is given, then this first part is against. This is what actually favoring. Therefore, P of A is equal to B by A plus B. What is it? P of A is equal to what? B by A plus B. Okay, first this is what we need to learn. This is what first we need to learn as far as favor and against is concerned. As far as favor and against is concerned, this is the first thing we learn. Okay, now, okay, so this is favor and against. So what are the things we have discussed so far, my dear? First, we discussed about types of events. In the last session, we discussed about types of events. We discussed about formulas. We discussed about formulas based on probability. Third one, the special event is independent event and the dependent event. This also we discussed. And today we are discussing about odds in favor and against. That is favor and against. So these are the things we are discussing, my dear. These are the things we are discussing. So far, the probability, at least to score minimum marks, at least this much you please learn and go. I think it will give very good marks, my dear. So rather going for a difficult question, different questions, let us start with this question only. Types of event, formulas, independent, dependent event, odds favor and odds against. At least this much you learn. Okay. The next part in probability is random variable. In random variable, what is all to be remembered? Okay, from random variables, what is all to be remembered? First one is expected values. Meaning of expected values is expected value of x is nothing but summation x into p of x, and expected value of x square is equal to summation x square into p of x. And this expected value of x also we call it as mean. This expected value of x also we call it as what? Mean. The expected value of x also we call it as mean. Okay. Then mean is equal to summation x into p of x. Next one is what? Variance. What is variance is equal to? Variance. Variance is nothing but expected value of x square minus expected value of x the whole square. Expected value of x square minus expected value of x the whole square. So variance is equal to expected value of x square minus expected value of x the whole square. Now in the examination, what type of questions can be asked, I'll tell you. Okay, the very simple type of question may be like this, like x, 1, 2, 3, something like kind of some variable will be given. Then probability of x also will be given to you. One is what 1 to the x value will be given to you, and the probability of x also given to you, like 3 by 5. Okay, 3 by 5, 1 by 5, 1 by 5. Okay, probability of x can be given to you. The question may be, they can ask you to find out find mean or find variance. This type of questions can be asked. In this case, what to be done, my dear? We have to find out x into p of x. That sum is going to be our mean. And next, we have to find out x square into p of x. This is our expected value of x square. Then after finding expected value of x square, in this formula, if you substitute, you'll get the variance also. You'll get the variance also. This is one type of question. It's a simple type of question. What is the second type of question? Is sometimes we need to prepare this table. Sometimes we need to prepare this table. Okay. If this type of questions are coming, that is, if we have to prepare the table, then it will be little, actually it will take little more time, my dear, because it will take little more time because it is not that simple to do it. It will take at least 2 to 3 minutes to solve the question. Okay. So when you just attend this random variable, you need to be very careful. Why? Because the question, that is whatever we are attending, there it should not be what? Time, whether we should not waste our time. So we have to decide whether should we attend or not. So without deciding anything, please don't go for it, my dear. So if the table has to be formed, then after that we have to find out mean and variance, which is actually will take a lot of time. So you have to be very careful before we start with this type of problem. Okay, fine. So mean we learn, variance we learn, and the type of problems also what this way they can ask if the table is given. If the table is given, then directly we can have what? If the table is given, directly we can have, okay, the table is given, therefore directly I can do what is mean and what is variance. Okay, fine, guys. Now, here, one more important thing, what exactly the students will commit a mistake, So they will start this type of sums, but they don't know how to take x and the p of x and all. Okay, so what we need to do when you read the question, there is, I think there may be a sum. Okay, I think in your textbook also, in your institute material also, we have got some problems. For JKC book, we have got problems. Please go through that problems, my dear. Okay, please go through those tables. And of course, when you just go through those problems and the table type, so obviously you will get some idea how to draw this table and how to convert it into expected value of x and expected value of x square and all. Okay, fine. So today I will do, definitely I will do a problem based on this. Okay, problem based on this, definitely I will be doing it. Now, let me start with the numericals from probability. Okay, so as far as the introduction is concerned, yes, can be some theoretical questions can be asked. Some theoretical questions can be asked from probability, but mostly there will be what numerical questions only will be asked. So let us prepare numerical questions. Okay, numerical questions means what? Finding probability. Okay, yes. Please download the material from the YouTube description, my dear. It is given in the YouTube description. Please download, because many students are keep on asking, sir, from where should I download? Where should I download? I think in the YouTube description it is given. Please download it from that YouTube description so that I think you can easily relate to my lecture, my dear. Okay. Now listen here. See, there are very important few formulas. Let me just revise again. P of A union B equal to P of A plus P of B minus P of A intersection B. If A and B are mutually exclusive, if A and B are mutually exclusive, then what is P of A union B is equal to? Because if A and B are mutually exclusive, if P and A and B are mutually exclusive, then P of A intersection B is equal to 0. P of A intersection B is equal to 0. So therefore, P of A union B is equal to P of A plus P of B. Sometimes it can be like this also. A and B are mutually exclusive These are very important MCQs, my dear, as well as exhaustive. Mutually exclusive as well as exhaustive. In this case, what exactly P of A union B is? P of A union B is nothing but, 1. Because exclusive means P of A union B equal to 1. Exclusive means P of A intersection B equal to 1. Exclusive means P of A intersection B equal to 0. And exhaustive means P of A union B equal to 1. Okay, the meaning of exhaustive is what? P of A union B equal to 1. Exclusive means P of A intersection B equal to 0. So therefore, our condition becomes P of A plus P of B is equal to 1. Okay, this is very important MCQ, my dear. This is very important MCQ. Okay, next important MCQ is, if A and B are independent, then P of A intersection B is equal to P of A into P of B. This is another important MCQ, my dear. What is P of A? If A and B are independent, then what is P of A intersection B is equal to P of A into P of B? It's another important MCQ. This is one important MCQ, and this is another important MCQ. And this one, mutually exclusive. This one is also another important MCQ, my dear. Okay, because sometimes they can ask, if A and B are mutually exclusive. Okay, if A and B are mutually exclusive, what is the condition? Or if P of A intersection B is equal to 0, then what is the relation between A and B? This kind of questions are very important questions. So please remember, if it is mutually exclusive, then we need to remember P of A intersection B is equal to 0. If it is mutually exhaustive, then P of A union B equal to 1. Okay, P of A union B equal to 1. Okay, yes. Now, with the problems, my dear. Let us start with the problems. Sum number 1. I hope you have downloaded the material. I hope you downloaded the material. The first question is what is given. If P of A intersection B, if P of A intersection B is equal to 0, then what about the events A and B? Events A and B are. Can you please tell me what exactly the meaning of P of A intersection B? Just now only I said, sir, if they are mutually exclusive, then P of A intersection B equal to 0, sir. So it is mutually exclusive, my dear. What is the answer, my dear? Mutually exclusive. That is option A. What is our option? A. Okay, option A is our answer. Now sum number 2. What is sum number 2? If A, B, and C are mutually exclusive and exhaustive events, say if A, B, and C are mutually exclusive, it is given as A, B, and C are mutually exclusive and exhaustive. I hope you know the meaning of exclusive and exhaustive. Exclusive is A intersection B intersection C is a null set. Okay, that is P of A intersection B intersection C is equal to what? 0. Exhaustive means P of A union B equal union B union C is equal to 1. So therefore, what will be the condition for P of A plus P of B plus P of C? Of course, it is equal to 1. Sir, you just taught me only for A and B, na, sir. See, this I taught, right? Sir, you taught me only for A and B, na, sir. Is it applicable for A, B, and C? Yes, my dear. Even for 3 events it is given, still it is applicable. Okay, even for 3 events it is given, still it is applicable. Okay. So that is what we need to understand. Mutually exclusive. What is it? Mutually exclusive. Now, come to sum number 3, my dear. Sum number 3. Variance of a random variable x is given by my dear. I think here we have done it, right? So this is what our variance. So this variance also can be written as expected value of x minus mu the whole square. This way we can write, or the same formula can be written as expected value of x minus expected value of x the whole square. See, we can write in both the ways, my dear. We can write it in both the ways. So here, the variance can be written like this, or the variance can be written in these 2 ways also. Okay. So in these 2 ways also we can write. So therefore, here for this question, for sum number 3, we have A or B. Both the options are applicable, my dear. Okay, both the options are applicable, A or B. Okay, either A or B. What is it? Either A or B. Therefore, option D is our answer. For sum number 3, what is our answer, my dear? Option D is our answer. Now, come to sum number 4. What is sum number 4 is? What is sum number 4 is? If a card drawn at random from a pack of 52 cards, what is the chance of getting spade or an ace? Okay, what is the chance of getting spade or an ace? Of course, you know what is playing cards. See, let me just, the people who are doing it for the first time, or people may not aware about it, for them, let me explain. Playing cards, there are 52 cards. And that 52 cards, I'm just going to divide into 2 colors. One is black color and the other one is red color. There can be black color cards and there can be red color cards. There will be 26 black cards and 26 red cards. In black, we have got 2 types, that is 2 suits. Okay, one is spade and the other one is club. In red, we have got 2. Okay, in red also we have got 2. One is heart and other one is diamond. Heart and a diamond. What is it, my dear? Heart and a diamond. And each suit will have 13 cards. Each suit will have 13 cards. Each suit will have 13 cards. What are those 13 cards? I'll tell you. What are those 13 cards? That is each card. What are those 13 cards? See, the 13 cards can be bifurcated into 3 parts again. One is number cards. Second one is face cards. Third one is ace cards. Okay, there are 9 number cards. How many number cards? 9 number cards, 4 face cards, and 4 ace cards. Okay, sorry. 9 number cards, 3 face cards, and 1 ace card in from each suit. From each suit, there will be 9 number cards, 3 face cards, and 1 ace card. What are the face cards? Jack, Queen, King. These three are face cards. What is ace card? Ace. That is ace cards. Now, what are the number cards? 2, 3, up to 10. These are our number cards. So, each suit will have 13 cards, and this is the bifurcation of all the 13 cards. These are the bifurcations of all the 13 cards. 2 to 10, that is number cards, JQK, face cards, and ace cards. Okay. These are the bifurcation of each suit. These are the bifurcation of each suit. First, you remember it, my dear. Now, listen here. Every suit will have ace card. So there are total how many ace cards? Total how many ace cards? Total there will be 4 ace cards in a pack of 52 cards. Total there will be 4 ace cards. And how many face cards? Because each suit will have 1 jack, 1 queen, 1 king. That means each suit will have 3 face cards. So total there are 4 suits. Therefore, how many face cards, my dear? 48 face cards. Sorry, 12 face cards. What is it? 12 face cards. Because each suit will have what? 3 face cards. There are 4 face cards. There are 4 suits. Therefore, 4 threes are 12. Next, number cards. Each suit will have 9 number cards. So total there are 4 suits. So total number of number cards is 36. Now total we are getting 52. Okay. So this is very important point we need to remember, my dear. Now in this case, what we can do, sum number 4 is, what exactly given? If a card is drawn at random from a pack of 52 cards, what is the chance of getting spade or an ace? What is the chance of getting spade or ace? What is the chance of getting spade or ace? Of course, you remember the formula. What is P of A union B is equal to P of A plus P of B minus P of A intersection B. I hope you remember it. Is that right? Yes or no, my dear? I hope you remember it. Now look at this. Total, how many spade cards are there? Total, there are 13 spade cards, sir. So what is the probability of getting spade cards? 13 by 52 plus, after that, ace cards. Total, there are how many ace cards? 4 ace cards are there. Therefore, which is nothing but 4 by 52 minus. Is there is any common element between spade and ace? Of course, sir. In every spade, that is in total, in every spade, okay, suit spade, 1 ace will be there. So here in this spade card, ace is included. In this ace card also, spade ace is included. So in both the places we have included, my dear. In both the places we have included. So therefore, what we need to do is we have to remove it. That is what our intersection. That is what our intersection. Therefore, 1 by 52 should be removed. So our answer is 16 by 52 can be written as 4 by 13. What is it? 4 by 13 is our answer. Please understand, my dear. Spade or ace. Spade or ace. Probability of spade card is 13 by 52. Probability of ace card is 4 by 52. And there is an intersection between spade and ace. There is one card with spade and ace, which is 1 by 52. So answer is what? 16 by 52, which is 4 by 13. What is it, my dear? 4 by 13. Okay. That is our option A. Fine. Next one. What is the next question is given, my dear? Fifth one. Just listen this very carefully. It is a formula method sum. P of A is equal to 1 by 2. P of B is equal to 1 by 3. And it is given as P of AB. What is given, my dear? P of AB. P of AB means P of A intersection. If it is given AB, we have to consider as what? P of A intersection B. What is it, my dear? P of A intersection B. What is P of A intersection B is given as 1 by 4. P of A is 1 by 2. P of B is 1 by 3. P of A intersection B is equal to what? 1 by 4. Now the question is, find P of A dash given B dash. This is the question. What is the question, my dear? P of A dash given B dash is your question. P of A dash given B dash is our question. Sir, I know the formula for P of A given B, sir. What is the formula? It is nothing but P of A intersection B divided by P of B. This is the formula for P of A given B. You may be wondering, sir, from where we got this formula, sir? Of course, my dear, I hope you remember it. See, what is P of A intersection B is? P of A into P of B given A. I hope you remember this, right? Sorry, P of B given A. So now from here, what is P of B given A is? Bring this P of A to left hand side. P of A intersection B divided by P of A. P of A intersection B divided by P of A. Okay. So this is P of A. This is one formula, B given A. If it is B given A, P of A intersection B by P of A. If it is A given B, the formula is going to be P of A intersection B divided by P of B. Okay. Yes. Now, here, P of A given B is P of A intersection B and P of B. So therefore, what will be P of A dash given B dash is going to be? That is also going to be P of A dash intersection B dash divided by P of B dash. Is it clear, my dear? What is it? P of A dash intersection B dash divided by P of B dash. Okay, P of A dash intersection B dash divided by P of B dash. See, here A given B means A, B, B. If it is A dash given B dash, because the question is A dash given B dash, so wherever A is there, just replace it, my dear. A dash, B dash, just replace it. I think you will be able to get it. Now, fine. I know what is P of A, I know what is P of B, I know what is P of A intersection B. But they ask you to find out P of A dash intersection B dash. At least this I can write it as 1 minus P of B. Okay. Now I have to find out what exactly P of A dash intersection B dash is. So what is P of A dash intersection B dash is? I hope you remember the formula De Morgan's law. P of A dash intersection B dash is nothing but 1 minus P of A union B the whole dash. Sorry. 1 minus P of A union B. What is it, my dear? 1 minus P of A union B. 1 minus P of A union B. So what is 1 minus P of A union B? So here we need to find out A union B. So what is P of A union B is? P of A plus P of B minus P of A intersection B. Now we'll take LCM. LCM is nothing but 12. Therefore 6 plus 4 minus 3, which is nothing but 7 by 12. What is P of A union B is equal to 7 by 12? What is P of A union B equal to 7 by 12? Okay. P of A union B equal to 7 by 12. Now look at this. What is P of A dash intersection B dash is? P of A dash intersection B dash is nothing but 1 minus P of A union B. So 1 minus 7 by 12 is equal to 5 by 12. So first we'll be finding what P of A union B. First we'll be finding what P of A union B. Then I'll substitute here. So what is it? P of A dash intersection B dash is nothing but 5 by 12. And what is P of B dash? See, P of B is given as 1 by 3. So what is P of B dash is equal to 1 minus 1 by 3, which is 2 by 3. What is it? 2 by 3. So now 2 by 3. 4 times. So our answer is 5 by 8. What is our answer? 5 by 8. Sir, will these type of questions can be asked in the examination, sir? Of course, my dear, these type of questions, definitely they are asking in the examination. Okay, definitely they are asking in the examination. So we have to do it. Okay, definitely they are asking in the examination. Is it clear? So our answer is what? 5 by 8. Our answer is what? 5 by 8. Option C. Our answer is 5 by 8. Option C. Okay. Yes. Now, sum number 6. Read the question very carefully. What is sum number 6 is? If for two events A and B, P of A intersection B is equal to P of A into P of B. I hope you remember this. Sir, when A and B are independent, sir, when A and B are independent, sir, then P of A intersection B is equal to P of A into P of B. When they are mutually exclusive, P of A intersection B is 0. When they are independent, P of A intersection B is equal to P of A into P of B. Therefore, the two events A and B are what? Independent. Option A. What is it, my dear? Option A. Okay. Now, come to sum number 7. Addition theorem on probability. Of course, you know what is addition theorem on probability? P of A union B equal to P of A plus P of B minus P of A intersection B. This is our addition theorem on probability. So here what will be our option, my dear? C is our option. What will be our option? C is our option. Okay. Come to sum number 8. If a random variable x assumes, look at this, if a random variable x assumes x1, x2, x3 up to xn, and sorry, 4 up to 4 only they said, okay, and probabilities P1, P2, P3, P4. Next, what we have to do? Then the expected value of x. What is the expected value of x is? It is nothing but x into P of x. What is it? X into P of x. That means what will come, my dear? X1 P1, X2 P2, X3 P3, and X4 P4. Now its sum is our answer. What is it? X1 P1 plus X2 P2 plus X3 P3 plus X4 P4. In the examination, you are not supposed to draw this table. We don't have time for drawing these tables. Okay. In the examination, we are not supposed to draw the table. What we have to do, we have to just write the final answer like x1 p1, x2 p2, x3 p3, x4 p4. That is our option C. That is, we need to multiply the random variable and the probability. We need to multiply the random variable and the probability. So that is what our sum number 8 is. Okay. Now, come to sum number 9. What is sum number 9 is, if an unbiased die is rolled once, the odds in favor of getting point, which is multiple of 3 is, see, unbiased die is rolled once. That means what are the outcomes, my dear? 1, 2, 3, 4, 5, 6. Okay. The question is what? Odds in favor of getting multiple of 3. Odds in favor of getting multiple of 3. Odds in favor of getting multiple of 3. Now look at this, my dear. Multiple of 3. Here, 3 and 6 are multiple of 3. What is it? 3 and 6 are multiple of 3. 3 and 6 are multiple of 3. Now, odds in favor. Odds in favor is 3 and 6. Total how many outcomes? 2 outcomes. So, against how many are there? That is not multiple of 3. Against how many are there? 4 is there. Therefore, our ratio is nothing but 1 is to 2. Ratio is nothing but what? 1 is to 2. Don't write 2 is to 4 because ratio should be always written in simplified format. Ratio should be always written in simplified format. Okay, 2 is to 4 and all not allowed in ratio. We have to write it as 1 is to 2. What we need to write, my dear? 1 is to 2. Therefore, our option is A. So, what is our option? A. Yes. Next one. Sum number 10. What is it? If A, B, C are 3 mutually independent with the probability 0.3, 0.2, 0.4 respectively, what is P of A, B, C? First, let me write all the given information. P of A is given as 0.3, P of B is given as 0.2, and P of C is given as 0.4. This information is given. Also, one more information is given. A, B, C are independent. Even this information also given. Both the informations are given. If A, B, C are independent, we know the rule. P of A intersection B intersection C is nothing but P of A into P of B into P of C. You can think, sir, you said only for 2 events, no, sir. But here there are 3 events. But still you are writing, sir. Yes, of course, my dear. Even it is applicable for all the 3 events. So P of A into P of B into P of C, which is nothing but 0.3 into 0.2 into 0.4, which is 0.024. 0.024. Okay, you have to be very careful while marking the option because look at option B. Option B is given 0.24. Option B is given 0.24, but our answer is what? 0.024. So when these kind of confusions, these kind of mistakes we should not make. Generally, people does. So what they do? Okay, 3 to 6, 6 to 4, 24. So 0.24 is there. Option B will mark. No, it is option C, my dear. 0.024. What is it, my dear? 0.024. Okay. Yes. Sum number 11. What is the chance of throwing at least 7 in a single cast with the 2 dice? See guys, 2 dice problems. I'll just give you one table. I think this table will help you for 2 dice sums. What is it, What is the minimum sum when you throw 2 dice? What is the minimum sum? Sir, minimum sum is going to be 2, sir. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Maximum sum is equal to 12. Maximum sum is equal to 12. Minimum is what? 2. Maximum is 12. That means when you throw 2 dice, minimum sum 1, 1, and the maximum is what? 6, 6. That is 12. So if you remember this table, so what exactly happens, we can just solve 2 dice problem just like that. What is it, 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1. This is the table, my dear. For 2 dice, if you can remember this table, I think it will be more useful to you. Look at this, my dear. What is it? 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1. Okay, 1, 2, 3, 4, 5, 6, and 5, 4, 3, 2, 1. Now look at this, sir. What exactly we are trying to tell, sir? Now look at this, my dear. 1, 1, 1, 2, 1, 3. It goes on like this, right? Now, sum is 2. Only 1, 1 is possible, therefore 1. Sum is 3. What are the possibilities? 1, 2, and 2, 1. 1, 2, and 2, 1. These two are the possibilities, right? 1, 2, and that is what 2 here. Same way, sum is 4, sum is 5. All the possibilities are what? 1, 2, 3, 4, 5. When sum is 6, 5 possibilities. What are they? 2, 6. 2, 6. Sum is what? 6. Sorry. Sum is 6. 2, 4. 1, 5. 2, 4. 3, 3. 4, 2. Okay, 4, 2. And 5, 1. And what? 5, 1. So total there are 5 possibilities of sum is 6, right? So that's what I have written here. So if you remember the table, what exactly can happen is, the question is what? At least 7. What is at least 7? Minimum 7. Okay, what is at least 7? Minimum 7. So maximum sum is 12. So 7, 8, 9, 10, 11, 12, everything is possible. So therefore add everything. 11, 15, 14, 16, 17. Okay, what is it, my dear? Again, once again, let me tell you, 17. So 17 divided by total number of outcome is what? Total number of outcome is what? Actually 36. Total number of outcome is 36. Therefore, our answer is 17 by 36. What is our answer, my dear? 17 by 36. What is our answer? 17 by 36. Option D. Okay, what is it? Option D. Fine. Now, sum number 12. If one card is drawn at random, from a pack of playing cards, find the probability that it's neither hearts nor a club. It's neither hearts nor club. Okay, it's neither hearts nor club. Fine. So that means we have to find out probability of not hearts, not even club. This is what we have to find out. P of H dash intersection C dash. What is it? H dash intersection C dash. What is probability of H dash intersection C dash is? Which is nothing but P of H union C the whole dash. What is it, my dear? P of H union C the whole dash. What is it, my dear? P of H union C the whole dash. Okay, fine. Which is nothing but 1 minus P of H union C. That is heart or club. What is it, my dear? Heart or club. Fine. Yes. Next one. What is the question? Find the probability. Find the probability. Wait, my dear, I think my screen. Yes. Sorry for the disturbance, my dear. I think, see, actually, after this, I'm from Chennai, actually. After this cyclone, in my place, the network is going very poor. That's what I'm unable to use the board also. Okay, sorry for inconvenience, my dear. So please try to manage. Okay, probability of heart, neither heart nor clubs. So according to De Morgan's law formula, what is P of H dash intersection C dash is P of H union C the whole dash, which is number 1 minus P of H union C. What is H? Heart and club. So that means 1 minus, what is probability of heart? What is probability of heart? So it is 13 hearts are out of 52 plus there are 13 clubs are out of 52. Is that right? Sir, there is no intersection because they are mutually exclusive. Heart and club is not, there is no common card between heart and club, my dear. Therefore, only P of H plus P of C, which is nothing but 1 minus, this is 1 by 4, this is 1 by 4. So 1 by 4 plus 1 by 4, which is equal to 1 by 2. So 1 minus 1 by 2, our answer is 1 by 2. This is one way of approaching. This is one way of approaching. What is the other way of approaching? I'll tell you. Sir, it is neither club nor heart. See, this is school kids follow this method. Okay, but we are writing professional exams. When you write a professional exam, no need to write each and every step, and we can directly try to get the answer also. By reading the question, you can understand, sir. The question is hearts, neither hearts nor clubs, sir. That means the card can be what? The card can be what? Spade or diamond. Spade or diamond. Spade or diamond. Is that correct, my dear? Spade or diamond. Total, how many spade cards we have got? 13 spade cards. Total, how many diamond cards we have got? 13 diamond cards. So now the required card is going to be what? Either spade or diamond. So that is total, there are 26 spade or diamond cards out of 52. My answer is 1 by 2. Directly we can get like this. You got my point, my dear? See, this is what the school kids, by using the formula, we approach like this. But we are a professional students. When you are a professional student, our approach should be different. And this approach is possible, my dear. This approach is possible. Okay. Yes. Now come to sum number 13. What is sum number 13 is? 3 balls are drawn at random from a bag containing 6 blue and 4 red balls. So there is a bag, 6 blue and 4 red balls. Total, we have drawn how many balls, my dear? 3 balls. Okay, how many balls are drawn? 3 balls are drawn. How many balls are drawn? 3 balls are drawn. So my N of S is going to be, total there are 10 balls. Out of 10, 3 balls are drawn. This is my N of S. So what is 10C3? I hope you know what is 10C3. 10 into 9 into 8 divided by 3 into 2 into 1, which is equal to 3 3s are 9, 4 2s are 8. So 120. What is our 10C3 is equal to 120. Now, the question is, what is the chance that 2 balls are blue and 1 red? That means I have to find out 2 blue and 1 red. Is that right, my dear? 2 blue and 1 red. So 2 blue balls. So total there are 6 blue balls. So 2 blue balls possible, and the meaning of and is what? Multiplication. 1 red ball. So out of 4 red ball, 1 red ball divided by total. 6C2, when you simplify it, you are going to get 15 into 4 divided by 120, which is nothing but 60 by 120 is nothing but 1 by 2. So our option is C, my dear. What is our option? C. What is our option? C. Okay, C is our option. Fine. Okay. Now come to sum number 15. What is sum number 15 is? An investment consultant predicts that the odds against the price of a certain stock going up are 2:1, and odds are in favor of the price remaining same, 1:3. What is the probability that the price stock will go down? See guys, listen here. So this, we need to understand the question on our own and we have to answer this. Okay. See, this is, we are talking about stocks. Okay, what we are talking about the stocks. See, sometimes what happens, stocks can go up, stocks can come down, or stocks can remain same. So there are 3 possibilities. Okay, stocks can go up, can come down, or remain same. Or what? Remain same. There are 3 possibilities, and all the 3 possibilities are independent. All the 3 possibilities are what? Independent. Okay, all the 3 possibilities are independent. Actually, how we can say is all the 3 possibilities are exclusive, mutually exclusive, because all 3 or any 2 cannot come together. All 3 are mutually exclusive as well as exhaustive. Okay, these are the maximum 3 possibilities. See, if you're talking about investment concern predicts that the odds against in price. So see here, so here our investment, whatever we are investing, There are three cases, my dear. There are three possibilities. One is what? Can go up, can go down, or remain same. Okay, remain same. These are the three possibilities. Okay, these are the three possibilities. And all the three possibilities are mutually exclusive and also exhaustive. Okay, what is the condition for mutually exclusive as well as exhaustive? Which is nothing but P of A plus P of B plus P of C is equal to 1. This is what mutually exclusive as well as exhaustive. P of A plus P of B plus P of C is equal to 1. This is what mutually exclusive as well as what mutually exhaustive. Okay. Now listen here, my dear. Here it is given. An investment consultant predicts that the odds against price stock going up. Now look at this. Probability against is given. 2:1 against. So therefore, what will be my probability? I hope remember the probability is going to be 1 by 3, my dear. The second part is my favor part. Okay, second part is my favor part. So 1 by 3. Next. Odds in favor of the price remain same is 1:3. 1:3 is given as favoring. So therefore, what is P of B is equal to? P of B is equal to 1 by 4. Now the question is P of C to be found out. The question is P of C to be found out. So what exactly the condition is? P of A plus P of B plus P of C is equal to 1. So therefore, 1 by 3 plus 1 by 4. What is it? 1 by 3 plus 1 by 4, which is nothing but 7 by 12. Plus P of C is equal to 1. So therefore, P of C is equal to 1 minus 7 by 12, which is nothing but 5 by 12. Okay, 1 minus 7 by 12, which is nothing but 5 by 12. Okay, yes. So our option is A. What is our option, my dear? A is our option. Okay, yes, A is our option. Now, come to sum number 16. So those who wants to copy this, please write it down now. I'll wait for another 20-30 seconds. Please copy this. Okay. Now sum number 16. What is sum number 16 is? A pair of dice. What is it? A pair of dice rolled. If the sum of the two dice is 9, if the sum of the two dice is 9, find the probability that one of the dice shows 3. Listen here, my dear. Pair of dice is rolled. If the sum of the two dice is 9. Now look at this, my dear. What is the probability of getting 9? What is the probability of getting 9? Sir, it can be 3, 6, 4, 5, 5, 4, 6, 3. This is what? 9. Okay, total 9. These are the possibilities. Now the question is, find the probability that one of the dice shows 3. One of the dice shows 3. That means, look at this, my dear. Out of 4, these are the two possibilities, correct? So 2 out of 4 is my probability. What is 2 out of 4, my dear? What is my 2 out of 4 is? 1 by 2. What is 2 out of probability, my dear? 1 by 2. So our answer is option C. Our answer is what? Option C. Okay, our answer is what, my dear? Option C. Okay, our answer is option C. Is it clear? So here, look at this. Here, what happens, don't take all the 36 elements. Don't take all the 36 elements. Here, what happens? Sum is 9 is given. From that, we have to find one of them is what? 3. See, actually, this is the condition probability. What is the condition probability? Probability of sum is 9, such that one of the dice shows 3. This is what they ask you to find out. If you apply the formula, You will be using P of A intersection B divided by P of B. It's such a like what time waste. Okay, such a like time waste, my dear. So what you have to do, sir? Sum is 9, sir. If sum is 9, what should be done, sir? 3, 6, 4, 5, 5, 4, 6, 3, sir. This is what sum is 9, sir. There are 4 possibilities, sir. Out of 4 possibilities, 2 possibilities are having one number as 3, sir. So directly I can write 2 by 4, sir. Why should I use the formula? That's what, my dear, I'm also telling. It is 1 by 2. What is it? 1 by 2. Okay. Yes. Now, sum number 18. What is the probability of getting neither total 7? Okay, neither total 7 or nor 11 when the pair of dice tossed. Look at this, my dear. What is the probability of getting neither total 7 nor 11 when the pair of dice is tossed? That means they ask you to find out 7 dash intersection 11 dash. What they ask you to find out, my dear? 7 dash intersection 11 dash. Neither 7 nor 11. What exactly it is? Sir, this I know, sir, which is nothing but 1 minus P of 7 or 11, sir. Probability of getting sum is 7 or probability of getting sum is 11. Yes. What is the probability of getting sum is 7, my dear? That is nothing but our probability formula. P of 7 plus P of 11 minus P of 7 intersection 11. This is the formula. Now, please remember one thing. This one, simultaneously, the number is 7 or 11. 7 and 11 is not possible because 7 and 11 means it is 77. When you throw 2 dice, maximum is 12. Therefore, they are mutually exclusive. So, therefore, this probability is going to be 0. Now, I'll be finding probability of 7. Probability of getting 7. What is it? Probability getting 7. So, what is 7 means? It is very simple, my dear. Probability of getting 7. Sum is 7. I think I have given the table. From the table also you can get it. What is probability of getting 7 is? Sir, 6, sir. So, therefore, our probability is 1 minus 6 by 36 plus probability of 11, only 2, 5, 6 and 6, 5. So, therefore, 2 by 36, which is nothing but 1 minus 8 by 36, which is nothing but 1 minus 4 by 9, which is 5 by 9. Our answer is what, my dear? Sorry, I think 8 by 36. This is 2 by 9. Sorry, it is 2 by 9. So, therefore, our answer is 7 by 9. What is our answer, is, my dear? 7 by 9. Okay, 2 by 9 is nothing but 7 by 9. Option A. See, that's it. Neither 7 nor 11. So, that is 7 dash intersection 11 dash. This is what we need to find out. Okay. Next one, sum number 19. What is sum number 19 is? What is the probability that a leap year? Please remember one thing. This is a very important type of question. Okay. One is what? Leap year. Other one is non-leap year. Okay. Leap year and non-leap year. Listen here, my dear. Every year will have 52 Sundays, 52 Mondays, 52 Tuesdays. Every year will have all the 7 days for 52 times. Okay. If it is non-leap year, for getting 53rd Sunday or 53rd Tuesday, directly you can write it as 1 by 7. For non-leap year, our answer is 1 by 7. And for leap year, 2 by 7. Please remember, in the examination, we are not supposed to do these kind of sums. We have to remember the answer and we have to write it. That's it. Sir, non-leap year, sir, probability of getting 53 Sundays or 53 Mondays is going to be 1 by 7, sir. If it is a leap year, sir, probability of getting 53 Sundays or 53 Mondays, it is going to be 2 by 7, sir. This is what we need to understand. Now the question is what? We have to get 53 Sundays or 53 Mondays. 53 Sundays or 53 Mondays. Okay. 53 Sundays or 53 Mondays. Okay. 53 Sundays or 53 Mondays. This is what we need to find out. Okay. What is probability of getting 53 Sundays or 53 Mondays? See, our sample space is going to be Sunday, Monday, Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Saturday, Sunday. Now, probability of getting 53 Sundays. Sir, 1, 2, sir. That's what I said, 2 by 7. Probability of getting 52 2 Mondays, sir, 1 and 2, sir. Sir, here there is a problem because this Sunday, Monday, here also comes, sir. Therefore, they are not mutually exclusive, sir. They are not mutually exclusive. Therefore, let us find out that probability also. The Sunday, Monday comes in both the cases. Therefore, minus 1 by 7. So, our answer is 3 by 7. Our answer is what? 3 by 7. Mostly where the students are committing mistake is, they'll be writing 4 by 7. So 4 by 7, sir, and my answer is correct, sir. That's what they'll be thinking. But they ignore this minus 1 by 7. What is this minus 1 by 7, my dear? It is Sunday, Monday. What is it? Sunday, Monday. It's an intersection part. For Sunday also this part comes. For Monday also this particular element comes. Therefore, it has to be removed. So therefore, our answer is 3 by 7. So where the people are committing mistake, my dear, when they forget to subtract this minus 1, that is 1 by 7. Okay. Yes. So our answer is 3 by 7. Our answer is what? 3 by 7. Okay. Next one. Sum number 20. What is sum number 20 is, if A and B are two evens such that P of A is equal to 1 by 4, P of B is equal to 1 by 3, P of A union B equal to 1 by 2, the question is, find P of B given A. What is it, my dear? P of B given A. What is P of B given A is nothing but, I hope you remember the formula now. So it is nothing but P of A intersection B divided by P of A, sir. What is the P of A intersection B divided by P of A, sir? Fine. So the information, sir, given says what? P of A is given, P of B is given, P of A union B is given, P of A intersection B is not given. But you can easily find out P of A intersection B. P of A intersection B is equal to P of A plus P of B minus P of A intersection B. Sorry, union B. You may be wondering, sir, this formula is not there only, sir. We have formula for P of A union B, sir. What is P of A union B? P of A plus P of B minus P of A intersection B, sir. But you are writing reverse order, sir. No, my dear. No. What I did was, A union B here, intersection B here. You will get the original formula. You will get the original formula. So, what I can find out? P of A plus P of B minus P of A union B. What is P of A is? 1 by 4 plus 1 by 3 minus P of A union B. What is minus P of A union B is 1 by 2 divided by, what is P of A is equal to 1 by 4. Yes. Now LCM. LCM is 12. So what you'll get? 3 plus 4 minus 6, which is nothing but 1 by 12 whole divided by 1 by 4. So 1 by 12 by 1 by 4. My answer is 1 by 3. What is our answer, my dear? 1 by 3. Our answer is what? 1 by 3. Okay. Yes. Now, sum number 21. What is the probability of getting exactly 2 heads in 7 tosses of a coin? Look at this. Number of tosses? 7. And exactly 2 heads. Exactly 2 heads. Probability we need to find out. Yes. I will give you one shortcut here. You please, not only for 7 heads, even 7 coins, even for 20 coins, 30 coins, anything you can apply. Actually, this problem should be done by using binomial distribution. Binomial distribution is not needed. Just follow the shortcut. Look at this, my dear. And the shortcut is only applicable when probability of success or failure is 1 by 2. Okay, when the probability of success or failure is 1 by 2, like tossing a coin. Getting head is 1 by 2, getting tail also 1 by 2. It is 1 by 2, right? Probability of getting success or failure should be 1 by 2. Then only this possibility, that is tossing coin, true or false sum. So these kind of questions now, I think this shortcut will work, my dear. So answer directly what we can do, you know, exactly how many heads? Sir, 2 heads, sir. So that means 7C2 divided by 2 power 7. Sir, why 2 power 7, sir? 2 is head and tail. Number of times tosses? 7 times. Therefore, my number of sample space is going to be 2 power 7. Therefore, my sample space is going to be 2 power 7. So 7C2 by 2 power 7. What is it? 7C2 by 2 power 7, which is nothing but 21 divided by 128. What is it? 21 divided by 128. This is what our option D. Okay. This is what option D. Is it clear, my dear? So here, as far as this book is concerned, I think this many questions are given, but there is one coverage which I would like to give, which is nothing but random variables. I want to do two sums based on random variables because those two sums are most expected questions. Okay, very highly expected questions. So let me do both the sums. Okay, both the type of sums. Definitely, what if the random variable sum comes, so it will be from these two only. Okay, it will be from these two types of questions only. So let me just do it. Okay. Before that, you please copy and other questions. Okay, let me take the question now. I'll be writing the question on the board itself. Okay, fine. Yes. Okay. Please write the question with me, my dear. Question is, there are 5 white and 3 black balls. 5 white and 3 black balls in a box. 3 balls are taken at random. 3 balls are taken at random from the box. Find the expected number of black balls. Yes. There are 5 white and 3 black balls in a box. 3 balls are taken at random from the box. Find the expected number of black balls. Find the expected number of black balls. Okay. Now look at this. This question, this type of question, it can be asked in the examination, my dear. There is a box. 5 white, 3 black. Now,
Therefore, my
this is going to be n of s is nothing but 8c3. Or n of s is going to be what? 8c3. Okay. What is 8c3? 8 into 7 into 6 by 3 into 2 into 1. 3 2s are 6. Okay, 56. As I told you, this type of sums are little time consuming. You have to. What exactly the question is? Find expected number of black balls. What is it? Expected number of black balls. Okay. Find the expected number of black balls. So here, x and p of x, we have to prepare the table, my dear. And we need to find out x into p of x. That's it. Now, expected number of black balls. There can be no black ball. There can be 1 black ball. There can be 2 black balls. Or there can be 3 black balls. All 3 are black balls. Okay. That is no black ball. These are the possibilities, right? What is it? 0 black. That means what? All are white. All 3 are white. 1 black. And remaining 2 are white. 2 blacks. 1 is white. 3 black. No white. So what is probability of getting no black ball? That is all 3 are white. It will be 5c3 divided by 56. So 5c3 is what? 10 by 56. Next, 1 black and 2 white. What is 1 black and 2 white? 1 black is 3c1. 2 white is what? 5c2 divided by 56, which is nothing but 30 by 56. Next, 2 black and 1 white. That is 3c2 into 5c1 divided by 56, which is nothing but 15 by 56. Finally, all 3 are black. That means only one way of getting it. That is 3c3, which is nothing but 1 by 56. Now we need to just check, my dear. The sum should be equal to 1. Just check 10, 40, 55, 56, 56, 1. Yes, it is coming now. Next one is x into p of x. So this sum is going to be my answer. 0 into 10 by 56, 0. 1 into 30 by 56, 30 by 56. Don't waste your time by simplifying these things. Don't waste your time by simplifying these things. Leave as it is. Next is 30 by 56 again. Sir, why sir? 2 into 15 by 56, that is 30 by 56. Then finally 3 by 56, which is nothing but 33. 63 by 56 is our answer. What is it? 63 by 56. Now, if you want to use calculator, you can use it. What is 63 by 56 is? What is 63 by 56? Think 9 by 8. What is it, my dear? 9 by 8. So our answer is what? 9 by 8. So expected value of getting blue balls is black ball is 9 by 8. So in this question, what exactly happens? We ourselves, that is finding the table. From the table, we are getting the expected value. From the table, we are getting the expected value. So unlike other topics, like what some tables are given, finding expected means it's quite simple one. But this type is little lengthy. I'm not saying it is very difficult, but it is lengthy. So when you just try to do this, you have to be very careful. So I can suggest you, we can keep these questions at last only, because once you start this, and even a small mistake you commit here, in the calculation, it will completely affect your solution, my dear, and it will be what you will start wasting your time on one particular sum. Okay, so selection of problems are very important, whereas the kind of professional exams are concerned. Okay, total 100 questions are going to be there. Out of 100 questions, don't think that we have to attend all 100 questions, because sometimes what happens, in 2 hours time, 100 questions may be a little difficult also. So at least we need to ensure to attend 70 to 80 questions. Sir, I know these sums very well, sir, but I think if I start doing it, I may waste my time, sir. Then what to do, sir? Of course, my dear, if you start wasting your time, let us not think about this particular type of sum only. We'll keep it aside. After completing the simple questions, once you get the confidence, yes, now I have 10, 15 minutes extra. Now I can do wonders. So at that time, you can select this question and you can solve for the 1 mark. Otherwise, what exactly going to happen? It will be, you will take a lot of time to solve this question, my dear. So that is the drawback here. Okay. So next one, I told you there is one more sum I will be doing. This type of questions can be asked in the examination, my dear. So what exactly X is 2, 3, 4, 5, 6, 7, 8, 9, 10. What is X is? 2, 3, 4, 5, 6, 7, 8, 9. And P of X is given as 0.05, 0.1, 0.3, 0.2, 0.5, sorry, 0.05, 0.1, 0.05, 0.1, and 10, 0.05. When you add, you will be getting 1 only, of course. When you add, you will be getting 1 only. Now look at this, my dear. We need to find out expected value of X. See, this questions are all coming, so you should not leave this question, my dear. Definitely you have to attend this question. I think you'll be using your calculator. You take the calculator, do what I'm saying. 2 into 0.05 m plus 3 into 0.1 m plus 4 into 0.3 m plus 5 into 0.2 m plus 6 into 0.05 m plus 7 into 0.1 m plus 8 into 0.05 m plus 9 into 0.1 m plus 10 into 0.05 m plus MRC. This is your answer. This is our expected value of X. See, in the question paper, this table will be given to you. What you will do, sir, I'll take the calculator, sir. I'll do 2 into 0.05, 3 into m plus 3 into 0.1 m plus 4 into 0.3 m plus, 5 into 0.m plus, 6 into 0.05 m plus. I'll keep on doing it, sir. Then finally, whatever sum I'm getting, that is my answer. Okay, whatever sum I'm getting, that is my answer. I hope you have done it. Okay, take the calculator and do it, my dear. Take the calculator and do it and find the value of expected value of x. Okay, so that's all with the probability. See guys, when you want to watch the probability lecture, how to watch, the previous lecture, last 20-30 minutes, I explained the probability theory part. And now the morning, that is the first session also, I started with what, probability, small basics. Then after that, I continued with the numerical sum. Please don't get scared about the probability. People will say, without knowing permutation combination, you cannot solve probability. Of course, my dear, probability is what, it's a combination of three topics like set, relation, function, set, especially set, permutation combination, then what? The mixture of these two only probability. Okay, if you know these two, probability is very simple. But it doesn't mean that, sir, in the examination, I'm planning to keep this chapter, like what, the permutation combination. I may not be, I may not get time, sir. I'm not getting the confidence. So then what to do, sir? Can I leave, sir? So if I leave permutation combination, of course, I have to leave probability also. So that is what the people mindset is. It is not like that, my dear. I'll tell you, if 5 to 6 questions are expected from probability, maybe this permutation combination application, maybe 2 to 3 marks can come. Minimum 2 marks, that's it. But still, for a safer side, I'm taking 3 marks also. But still, you will be able to attend 3 questions, my dear. So why I'm telling this, so if you are opted out for January, we have got time for preparing the entire thing again. But if you are just going for writing this exam in the month of December, you are going to write. That means you have already prepared, okay? That means you already prepared well. Now, don't change the pattern. And no need to, sir, I'm not prepared to this permutation combination, sir. Can I postpone my attempt, sir? That is also not necessary. It is not a big deal. So if you don't know, and for that, if you have to wait for another 1.5 months, is not necessary, my dear. So what we can do, sir, I know the basic concepts of probability, sir. Of course, that is more than enough to score 3 to 4 marks on probability. Okay, it is more than enough. Don't think, sir, I don't know whether I will be able to do this or that. See, don't worry about it, my dear. See, probability is the very simple topic. Okay, of course, 1 or 2 questions may be challenging, but ignore those questions. So I always used to tell my students one thing, my dear, you should know when to say no. Okay, sometimes, okay, let us not fight out the rear, let us say no. I don't want to attend this question. You should know when to say no. That is very important in professional exam, this kind of professional type of examination. In the 12th standard attitude, what we'll do is we'll keep on solving each and every question. Sometimes we need to come out of this mindset. So always attending each and every question is not possible. Sometimes we have to come out of it and we need to think, okay, this question I know, the solution I know, but if I start doing it, it will take 5 minutes time. So let me not touch this now. We'll see later when I get time. Because what happens, I think 5 minutes you take. Sir, I just started, sir. I think 5 minutes is not a big deal, na, sir. The first question I know, but it will take 5 minutes. That also I know. So why don't I do it, sir? Because it's starting on dinner, sir. It's not a big deal. But here what happens, when you take a lot of time in the beginning, that you don't know how much time is going to happen. So in that 5 minutes time, after sometimes you may have what, you can get 20 marks also. Like all the theory questions together can be given. Okay, 5 minutes. Just we have to mark the solution, just like that. Tick, 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 tick. So 15, 20 marks we can score in 5 minutes. Sometimes in 5 minutes you will take more number of time also. It is actually what, it is up to you how much time you are taking, my dear. It is up to you how much time you are taking. So my suggestion is, you have to be very careful. Before we go for this topic, my dear. Okay, now I'm going to start with the next topic, like theoretical distribution. Small 10 minutes break, then I'll start with theoretical distribution. My time is 5. We'll be joining by 5. Theoretical distribution. People who want to keep this an option, after attending the lecture, definitely you'll think once again, because the coverage what I'm going to give is entered. I can give you this assurance, minimum 2 to 3 marks from theoretical distribution in that next 1.5 hours if you sit. Only theory I'm going to cover. Theory part I'm going to cover. Few numericals also I'm going to cover, of course, but especially theory, because mainly what theory questions will be asked. So please watch this lecture for next 1.5 hours. Definitely is going to be useful to you, my dear. So let us rejoin at 1:35. Let us rejoin at 1:35. Okay. Yes. Thank you. Welcome back. Yes, now listen here, my dear. We're going to start with the theoretical distribution now. Okay. So what exactly theoretical distribution? Theoretical distribution exists in theory as well as in real life. Okay. So as far as our syllabus is concerned, theoretical distribution actually bifurcated into two parts. As far as our syllabus is concerned, theoretical distribution is bifurcated into two parts. One is discrete distribution and the other one is continuous distribution. One is what discrete distribution and the other one is continuous distribution. I hope you remember the meaning of discrete and continuous. What exactly the meaning of discrete distribution is? When there is a probability distribution, when x is integer, then we call it as discrete distribution. When x is any real number, we call it as continuous distribution. We call it as what? Continuous distribution. Now, in this discrete distribution, we got two types of distributions, my dear. One is binomial distribution and other one is Poisson distribution. And in continuous, in our syllabus, we are going to learn about normal distribution. Okay, yes. Now, in binomial distribution, the other name of binomial distribution, we are going to call it as Bernoulli trial. What is it, my dear? Bernoulli distribution. What we can call? We can call it as Bernoulli distribution. What we can call, my dear? Bernoulli distribution. What is it? From Bernoulli distribution. Yes. See, as far as in binomial distributions are concerned, this bi stands for what? Sir, bi stands for 2, sir. Okay. Bi stands for 2. The 2 can be success or failure. Okay. The 2 can be what? Success or failure. Okay. Success or failure. The 2 can be what? Success or failure. Okay. And one more very important thing here, this discrete distribution, as far as our syllabus is concerned, there is a discrete binomial and a Poisson only will take positive integers. But actually discrete is what? It can take the negative integer also. But in binomial distribution, Poisson distribution, x we are going to always take it as what? Positive integer. Okay, what you are going to take? Positive integer. That is -2, x value -2, -3 and all not possible in binomial as well as Poisson, my dear. Okay, binomial and Poisson definitely it is not possible. Okay, now each trial must associated with two mutually exclusive and exhaustive outcomes, success and failure. Okay, each trial must be associated with two mutually exclusive and exhaustive outcomes, that is success and failure. Generally, we denote success as P and failure as Q. Generally, we denote success as P and failure as Q. What exactly Q is? 1 minus P. That is what our Q is. What is our Q is? 1 minus P our Q. Okay, what is our Q is? 1 minus Q. Now, the trial must be independent. The trial must be independent. Okay, the trial must be independent. So let me write a few important points. Binomial distribution. It's a discrete distribution. Okay, the trials are independent. The trials are independent. Okay, and it deals with two outcomes. Two outcomes, success and failure. Two outcomes, success and failure. Okay, two outcomes, success and failure. And both are what, my dear? Mutually exclusive as well as exhaustive. Okay, whenever we talk about binomial distribution, this is the way we need to prepare the last derivation, my dear. What is binomial distribution, sir? It's a discrete distribution, sir. See, whatever I'm covering, all are one word questions. That is MCQ questions. And all that is, these are MCQ questions only I'm solving now. The binomial distribution is a discrete distribution. The trials are independent. The trials are independent. And there are two outcomes, which are success and failure. And they are what? Mutually exclusive as well as what? Mutually exhaustive. Okay, they are mutually exclusive and mutually exhaustive. Okay. Now listen here, the probability of success and failure remains unchanged throughout the process. So this will not change. Okay. Now here in this discrete distribution function, what we are going to do is they are like probability mass function. What is it, my dear? Probability mass function. What exactly probability mass function is? PMF. What exactly probability mass function is? PMF. What is probability mass function is? PMF. Here, in this case, what exactly success we talk about? P, and failure we denote it as Q, which is nothing but 1 minus P. Now, what is probability mass function for a binomial distribution? What is probability mass function for a binomial distribution? Which is nothing but P of x is equal to x is NCx P power x into Q power n minus x. What is it, my dear? P of x is equal to x, NCx P power x into Q power n minus x. What is it? P of x is equal to x, NCx P power x into Q power n minus x. This is what probability mass function for a binomial distribution. Okay, probability mass function for a binomial distribution is what? NCx P power x into Q power n minus x. For example, in any question, what and all to be identified, I'll tell you. We need to find how many trials are there. That is, what is the n? Small letter n we have to identify. What is probability of success? That is, what is P, what is Q? Then after that, X. Once you identified this P, Q, N, and X, our question is solved there itself, my dear. Just apply it in the formula, and you will get it. Yes. Now listen here. My dear. So this one here, N and P are called parameters. What is N and P, my dear? They are called parameters. N and P are called parameters. What is N and P? N and P are called parameters. N comma P are parameters. And this is the way we write B, N comma P. It's a binomial distribution with parameter N comma P. Binomial distribution with parameter N comma P. So parameters N comma P. What are the parameters? Parameter is N comma P. So I can say it's a binomial distribution is biparametric. Distribution is biparametric. What is binomial distribution, my dear? Metric. Okay. What is binomial distribution? Binomial distribution is nothing but biparametric. Okay. Yes. Biparametric means what? The parameters are n comma p. The parameters are n comma p. Okay. The parameters are what? N comma p. Now, what is n stands for? N is number of trials. And what is p is probability of success. Okay, and what is Q is, which is nothing but 1 minus P, that is failure. Okay, what is that? Probability of success, that is 1 minus P. Now here, another important point, what to be remembered, I'll tell you. Look at this. Mean of a binomial distribution is nothing but NP. Mean of a binomial distribution is nothing but NP. Variance of a binomial distribution is NPQ. Mean of a binomial distribution is NP. And variance of a binomial distribution is NPQ. Here, repeatedly asked one question, repeatedly asked a question. Okay, repeatedly they are asking this question. So what is it, you know? In which distribution mean is greater than mode? Sorry, mean is greater than variance. So in binomial distribution, mean is always greater than variance. In binomial distribution, mean is always greater than variance. Okay, mean is always greater than variance. Now, variance, maximum variance of a binomial distribution is equal to n by 4. What is maximum variance is n by 4. What is maximum variance is n by 4. What is maximum variance of a binomial distribution? N by 4. What is maximum variance of a binomial distribution? N by 4. Now look at this. I'm just going to write one important MCQ again. So what is it, you know? See, first one. It is symmetric. It is symmetric when P is equal to Q is equal to 0.5. When P is equal to Q is equal to 0.5, it is what? Symmetric, my dear. What is this? Symmetric. When P is equal to Q is equal to 0.5, then the distribution is what? Symmetric. The distribution is symmetric when P is equal to Q is equal to 0.5. This distribution can be positively skewed or negatively skewed. It can be. Okay. The distribution can be what? Positively skewed, or it can be what? Negatively skewed. It can be what? Positively skewed or negatively skewed. So symmetric. The distribution is symmetric when P is equal to Q is equal to 0.5. It can be what? Positively skewed as well as what? Or negatively skewed. Okay. Mean is nothing but variance. Mean is equal to NP and variance is NPQ. And what is the relation between mean and variance? Mean is strictly greater than variance. What is mean is strictly greater than variance. Guys, I'm requesting all to write these points, my dear. I request you all to write these points. I can challenge you after I complete this. After I complete this, you take your institute material and please take set A questions, and I can challenge you each and every set A question you will be easily able to solve on your own. Please follow this, whatever I said, because whatever I cover now all are MCQs only. This you keep it as last day revision. What exactly can be done before you enter into the exam hall? You just open this book, just read and go, my dear. Okay. If something goes right, everything goes right, then obviously what I can surely tell you that last day revision, what I'm going to do give now, and from that at least minimum 2 marks you will be able to score, my dear. Okay. Yes. So mean is greater than variance. Mean is greater than variance. Now, mode calculation from binomial distribution. How to calculate mode from binomial distribution? See, mode is nothing but n plus 1 into p. What is mode is? N plus 1 into p. What exactly mode is, my dear? N plus 1 into p. Okay. Now, here there are two cases. Case 1. This n plus 1 into p can be an integer. Okay, can be an integer. Like what it can be a number, like 5, 6, anything you can get, or non-integer. These are the two possibilities. That is fraction. Okay, fraction or a decimal. But integer means what? No fraction. It's not a fraction, it's a number. Okay, non-fraction. So, for example, if it is integer, if n plus 1 into p, I'm getting integer, then please remember this. There are always two modes, and the modes are n plus 1 into p and n plus 1 into p minus 1. See, if they are integer, if n plus 1 into p, if you are getting it as an integer, if it is an integer, then always there will be two modes. One mode is n plus 1 into p, and the other mode is n plus 1 into p minus 1. Let me give you one example, my dear. Let me give you one example. For example, n is equal to 15. N is equal to 15. Okay. P is equal to 1 by 4. Okay, P is equal to 1 by 4. What exactly mode is equal to? What exactly mode is equal to, sir? I know the formula, sir. N plus 1 into P. You will find n plus 1 into P. What is it? Sir, 16 into 1 by 4, sir. I am getting 4. If 4 is integer, 4 is integer. Therefore, it's bimodal, and the modes are 4, 3. And the modes are what? 4, 3. It can be bimodal. What is it, my dear? It can be bimodal. Now, when it comes to n plus 1 into, that is when it comes to, this is for integer. When it comes to integer, there are two modes. Okay. When it comes to non-integer, that is what our case 2. When it is in fraction, and it is unimodal, so it is what? Unimodal. Okay, what is it, my dear? Unimodal. And what is it? Greatest integer integral value. What is it, my dear? Greatest integer integral value. Sir, I did not get this, sir. What is my greatest integer integral value? For example, 3.5 you are getting. What is it? 3.5 you are getting. Our mode is equal to 3 only. Don't take approximate value. We are not supposed to take approximate value. We have to take in greatest integer. See, within the 3.5, what will be the greatest integer? 3 is going to be the greatest integer. Within the 3.5, 3 is going to be the greatest integer. Even if it is 3.9, even if you are getting 3.9, still the greatest integer is going to be what? 3 only. Still the greatest integer is going to be what? 3 only. So, if it is a fraction, so we have got what? It is unimodal. What exactly it is? Unimodal. And the mode is greatest integer integral value. Let me give you one example. Let me give you one example. For example, n is equal to 16 and p is equal to 1 by 4. Okay, p is equal to 1 by 4. Okay, so 1 by 4. Let me take 1 by 3. Let me take, because 1 by 4 already taken. So now, what exactly mode is equal to? What you'll get? What is mode is equal to, sir? 16 plus 1, 17, sir. 17 into 1 by 3. What you are going to get, my dear? So which is nothing but 5.67, sir. Okay. So therefore, our mode is equal to, you should not write 5.67. Our mode is 5 only. Greatest integer in 5.67 is what? 5 only. Greatest integer is what? In 5.67 is 5 only. Therefore, our mode is nothing but 5. So in this case, it is what? Unimodal. In this case, it is what? Unimodal. When it is integer, it is what? Bimodal. What is it? Bimodal. So therefore, binomial distribution, okay, therefore binomial distribution can be, therefore binomial distribution can be unimodal or bimodal. Okay, binomial distribution can be what? Unimodal or bimodal, unimodal or bimodal. Fine. Now let me revise everything once again, my dear. See, theoretical distribution exists in theory as well as in real life. Theoretical distribution classified into two parts. One is discrete distribution, other one is continuous distribution. In our syllabus, discrete distribution we have classified into two. One is binomial distribution, other one is Poisson distribution. Normal distribution is what? What is normal distribution? It is continuous distribution. These are the three parts we are going to learn in this theoretical distribution topic. In binomial distribution, what exactly binomial distribution? Some constraints or some important points are the trial should be independent. The trial should be independent. There are only two outcomes. The outcomes are success and the failure. And success and failure should be what? Mutually exclusive as well as exhaustive. Okay, mutually exclusive as well as exhaustive. Next step. This binomial distribution is a discrete distribution. It is bimodal. It is what? Bimodal or unimodal. It can be unimodal or it can be bimodal. Okay, it can be unimodal or it can be bimodal. Now the probability mass function of a binomial distribution is NCX p power x into q power n minus x. What is it? NCX p power x into q power n minus x. That is our binomial distribution probability mass function. Okay, probability mass function, that is PMF. So NCX p power x into q power n minus x. Now here n and p are parameters. Therefore, binomial distribution is a biparametric. What is binomial distribution is? Biparametric. Okay, what is binomial distribution is? Biparametric. Next one is, what is mean is equal to? What is mean is equal to NP? What is variance is equal to NPQ? What is mean is equal to NP and what is variance is equal to NPQ? And in binomial distribution, always mean is more than variance. In binomial distribution, always mean is more than variance. Next one, when you look at it, binomial distribution is symmetric when P is equal to Q is equal to 0.5. When P is equal to Q is equal to 0.5, the binomial distribution is symmetric when it is positively or negatively skewed. It can be positively or negatively skewed. It can be positively or negatively skewed. That possibility is also available. Now, here mean is NP, variance is NPQ, and the maximum variance is what? N by 4. What is the maximum variance? N by 4. Last part of binomial distribution, what we need to learn is mode. Mode is nothing but N plus 1 into P. This N plus 1 into P, N will be given to you, P will be given to you. We have to find out N plus 1 into P. Sometimes that N plus 1 into P can be an integer or can be a fraction. When it comes to integer, we have to take two possibilities, my dear. We have to take two possibilities. That is, what is it? By model actually, N plus 1 into P and N plus 1 into P minus 1. These are the two possibilities. Okay. When it comes to fraction, then it is unimodal. What we need to take? We need to take the greatest integral value, my dear. What do we have to take, my dear? Greatest integer integral value, greatest integer of integral value. That is what we need to take. Okay, greatest integer of integral value we have to take. Okay, so Whereas when you prepare binomial distribution, this is what we need to prepare, my dear. First, what we need to prepare, these are the few points which we need to prepare. Okay. So I am requesting you to copy this point, all the points, please note it down. Whatever points I said, please note it down. Definitely it is going to be helpful to you, my dear. This is what I said. You keep it as a last day revision. You keep it as a last day revision. I think your problem will be solved, my dear. Okay, fine. And I'm requesting not to keep this topic as an option. Okay, sir. I don't know. Somehow I'm not comfortable with theoretical distributions, sir. I'm planning to keep it as an option. Guys, please don't do that. It is very simple. It is very simple. At least theory part you cover and go. If you're, sir, I'm not happy with the numerical sums, let it be, no problem. You please go with the theory part. Whatever just I'm covering, at least look into that and go, my dear. Okay. Next one. Poisson distribution. What is it? Poisson distribution. Sir, in discrete distribution, already we are learning binomial distribution. What is the purpose of learning Poisson distribution also, sir? What is the purpose of learning Poisson distribution? See, in a binomial distribution, there are some limitations. When there are some limitations, we are not in the position to use the binomial distribution. The limitations are binomial distribution. The limitations of binomial distribution. The first limitation is binomial distribution is what? Actually, number of trials should be finite. But when it comes to infinite number of trials, then definitely binomial distribution is not applicable. When it comes to infinite number of trials, binomial distribution is not applicable. Okay, binomial distribution is not applicable. Next, when the probability of success is approaching to zero, and NP should be finite. See, n is infinity, P is what? Approaching to zero, and NP is finite. So these are the limitations of a binomial distribution. So in this case, we have to use what, my dear? Poisson distribution. Okay. In this case, what you have to do? Poisson distribution. The distribution of limiting case of binomial distribution. When n tends to infinity, P tends to zero, and NP is finite. Okay, and NP is what? Finite. So then we can use Poisson distribution. Here in this syllabus, we are going to use NPS. We are going to use NPS M. We are going to use NPS what? M. Okay, in this goes, we are going to denote NPS M. Okay, we are going to denote NPS M. Okay, yes. Yes, we are going to denote NPS M. Okay, now listen here. So these are the limiting cases of binomial distribution. So Poisson distribution is applicable when in a binomial distribution, number of trials is infinite, P tends to zero, and NP is finite. What is it? P tends to zero and NP is finite. So in this case, we have to use Poisson distribution. In this case, we have to use Poisson distribution. Sorry. In this case, we have to use Poisson distribution. Okay. Now, Poisson distribution is also what? It's a discrete distribution. It's a discrete distribution. Hence, it's a probability mass function. Okay. So, what is probability mass function of a Poisson distribution is? So what is the probability mass function of a Poisson distribution? The probability mass function of a Poisson distribution is P of x is equal to x is equal to e power minus m power x divided by x factorial. See, in your school level, you might have learnt in the name of this m as lambda. Okay, this is m as what? Lambda. So either you can put lambda or you can put it as m. That is up to you, my dear. This m is nothing but our np. Okay, here this m is our parameter. What is it, my dear? M is our parameter. What is it? M is our parameter. M is our parameter. Therefore, Poisson distribution is uniparametric. What is it? Uniparametric. See, binomial distribution was biparametric and Poisson distribution is what? Uniparametric. Okay, Poisson distribution is what? Uniparametric. It was biparametric and Poisson distribution is uniparametric. There is exactly only one parameter. What is it? There is exactly one parameter. What is it? M only. Now, what is mean? Mean of a binomial distribution, sorry, Poisson distribution is nothing but M. Mean of Poisson distribution is M. Okay. Variance also M. What is it, my dear? Variance also M. Sir, that means in binomial distribution, sorry, in Poisson distribution is mean equal to variance, sir? Of course, my dear. In Poisson distribution, mean is nothing but variance. In Poisson distribution, what is mean is nothing but variance. In Poisson distribution, what is mean is nothing but variance. So mean is variance, my dear. What is it? Mean is variance. Mean is equal to variance in Poisson distribution. In binomial distribution, mean is greater than variance, strictly greater than variance. In binomial distribution, mean is strictly greater than variance. In Poisson distribution, mean is equal to variance. What is it? Mean is equal to variance. Okay, fine. So mean is M, variance is M, again M. So therefore, what is standard deviation is, my dear? Standard deviation is nothing but root of M. What is standard deviation is? Standard deviation is nothing but root of M. So mean is M, variance also M equal to M, and the standard deviation is what? Root of M. Now, mode. As far as mode is concerned, again there are two types of mode, my dear, here also. So here mode is what? We are going to take it as M. What you are going to take? M. So there are two things. One is what? That is mode is nothing but M. One is what? Integer. And other one is what? Non-integer. If it is integer, there are two modes. If it is integer, there are two modes. One mode is M, the other mode is M minus 1. If it is non-integer, it's a unimodal, that is highest integral value, greatest integral value. The previously what we have done the same thing only. Okay, this M only. Greatest, what is it, my dear? Greatest integer. Okay, what is it? Greatest integer. What is it? Greatest integer. Okay, what is it? Greatest integer. Here, bimodal and this is unimodal. Therefore, like Poisson distribution, like binomial distribution, Poisson distribution also what? Unimodal as well as what? Bimodal. Or unimodal or bimodal. Poisson distribution is what? Unimodal or bimodal. Okay, unimodal or bimodal. When it will be bimodal? When M is integer, we are going to get M and M minus 1. That is bimodal. When it is non-integer, we are going to have unimodal. Okay. So this is what we call about mode. Okay, this is what we are talking about mode. So mode, integer, non-integer, M and M minus 1. Fine. M is what? Greatest integer. What is M is? Greatest integer. So at least this much you need to learn as far as Poisson distribution is concerned. As far as Poisson distribution is concerned, this is what we have to learn, my dear. So next one is very, 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 very important point, which is normal distribution. What is it? Normal distribution. What you are going to learn, my dear? Normal distribution. See, this normal distribution is a continuous distribution. What is it, my dear? It's a continuous distribution. Normal distribution is nothing but what? Continuous distribution. Normal distribution is nothing but what? Continuous distribution. Okay. That is what X can be any real number. What is it? X can be any real number. Now, when you want to learn about normal distribution, the very, very important thing what we have to do is, very important thing what you have to do is, we should know about the Bell diagram. I hope you copied this. We should know about the bell diagram. What is it? Bell diagram. Okay. Bell diagram. What is it? Bell diagram. Yes. See, what exactly is the meaning of bell diagram? So let me just talk about bell diagram. See, it's a bell-shaped curve. It's a bell-shaped curve. Okay. It is a bell-shaped curve. Next one is, this is the tail. Tail will never touch the axis. Okay. Tail will never touch the axis. And it is also symmetric. What is it? Symmetric. Sir, what exactly is the meaning of symmetric, sir? Symmetric in the sense, mean is equal to, median is equal to mode. This is what symmetric. Okay, what is it? Mean is equal to, median is equal to mode. What is symmetric, my dear? Mean is equal to, median is equal to mode. Okay, mean is equal to, median is equal to mode. Now it is between minus infinity to plus infinity. The area under the curve is what? Minus 15 to 15 plus infinity. And generally what you know, we use x as random variable. What is x as random variable? But when I use z, this is actually normal variable. What is it? Normal variable. Okay. What is x is random variable? Z is normal variable. X is random variable. Z is normal variable. How to convert normal variable into random variable? How to convert normal variable into random variable? Z is equal to x minus mu divided by sigma. So what is z equal to? X minus mu divided by sigma. See, x is random variable. Sorry, x is random variable. Z is normal variable. And the conversion of z, that is how to convert into random variable to normal. Z equal to x minus mu by sigma. X minus mu by sigma. What is it, my dear? X minus mu by sigma. So z is x minus mu by sigma. Fine. Next one. See, x is random variable, z is normal variable, z is equal to x minus mu by sigma. It's a bell-shaped curve. It is symmetric, and the tail will never touch the axis. Area under the curve minus infinity to plus infinity is always equal to 1. My area under the curve minus infinity to plus infinity is what? Always is equal to 1. What is the area under the curve, my dear? What is the area under the curve? It is equal to 1. Okay. Now, that full area is 1. What about this portion, my dear? This is 0.5 and this is 0.5. That means area under the curve minus infinity to 0. And area under the curve 0 to infinity is always 0.5. See, I'm just writing whatever points I'm writing now, they are important MCQs, my dear. They are important MCQs. Area under the curve between minus infinity to infinity is 1. Area under the curve minus infinity to 0. And 0 to infinity is always equal to what? 0.5. What is it equal to? 0.5. What is it equal to? 0.5. Okay. Yes. Okay. Now, this is our z and x minus mu by sigma. Yes, fine. I think please note it down, my dear. Okay. Next one is, we have to talk about point of inflection. What is it? Point of inflection. So we are taking something like that. Point of inflection. Yes. What is point of inflection? You know, it is mu minus sigma to mu plus sigma. Mu minus 2 sigma. This is mu plus 2 sigma. See, this is our point of inflection, but mu minus. Now the area we are dividing, my dear. This is mu minus 3 sigma to mu plus 3 sigma. Okay. Now listen here. The area between mu minus sigma to mu plus sigma, the area covered between mu minus sigma to mu plus sigma, area covered between what? mu minus sigma to mu plus sigma. Area covered between mu minus sigma to mu plus sigma is nothing but 68%, my dear. 68% of the area will be covered between what? Mu minus sigma to mu plus sigma. How much area? 68%. Okay, what is the area, my dear? 68%. Okay, 68% is covered between mu minus sigma to mu plus sigma. Okay, 68% covered between mu minus sigma to mu plus sigma. That is approximately I'm talking about. If it is exactly, if I have to talk about, then it is 68.26 percentage. Now, mu minus 2 sigma to mu plus 2 sigma. What is it? Mu minus 2 sigma to mu plus 2 sigma covers 95.44 percentage. Mu minus 2 sigma to mu plus 2 sigma covers 95.44 percentage. Then mu minus 3 sigma to mu plus 3 sigma covers 99.73 percentage. See, this question is repeatedly they are asking. Now, okay, the area covered between mu minus 3 sigma to mu plus 3 sigma is what? 95%, 65%, 68%, all except to 0.27%. See, actually this is 99.73 means what? Almost the entire area we covered except to 0.27 percentage area. Except to 0.27 percentage area, we have covered the entire portion, right? So this is what? Mu minus 3 sigma to mu plus 3 sigma. Area covered is what? 99.73%. Mu minus sigma to mu plus sigma, area covered is what? 68.26. Mu minus 2 sigma to mu plus 2 sigma, it is 95.44 percentage. Okay. Yes. Now, see, once again, let me tell you, my dear, normal distribution is a continuous distribution. Okay. And it's a bell-shaped curve. Symmetric. The meaning of symmetric is what? Mean is equal to median is equal to mode. Okay. The tail will never touch the axis. The area, the complete area is what? 1. Area between minus infinity to 0 and 0 to infinity is 0.5, and x is random variable and z is normal variable. And how to convert z into x into z? It is z equal to x minus mu by sigma. Next one is we are going to divide the bell-shaped curve between what? Mu minus sigma to mu plus sigma, mu minus 2 sigma to mu plus 2 sigma, mu minus 3 sigma to mu plus 3 sigma. And next we have to discuss about area coverage. What is area coverage? Area covered between mu minus sigma to mu plus sigma is 68%. That is 68.26%. Area covered between mu minus 2 sigma to mu plus 2 sigma, it is 95.44%. The area covered between mu minus 3 sigma to mu plus 3 sigma, which is 99.73%. Of course, you are aware, since it's a normal distribution, what we have to discuss, my dear, it should be a probability density function. What is it? Probability density function. Look at this, my dear. Here, discrete. Discrete means what? Actually, it is PMF, probability mass function. When it is continuous, it should be PDF, probability density function. What exactly it is? Probability density function. Okay, what is it? Probability density function. Okay, yes, probability density function. Now listen here, let me just write what is probability density function here. Probability density function of a normal distribution. These are very, very important points, my dear. So please don't ignore. So if luck favors, this directly will be asked in the exam. Okay. PDF. What is PDF? You know, P of x is equal to x e 1 by sigma root 2 pi into e power minus half into x minus mu by sigma the whole square. What is it? P of x is equal to x 1 by sigma root 2 pi e power minus half into x minus mu by sigma the whole square. And what is x is? X is always between plus infinity to minus infinity. It is minus infinity to plus infinity. Okay, once again, please remember, my dear, this is our probability density function. What is probability density function is 1 by sigma root 2 pi e power minus half into x minus mu by sigma the whole square, where x is between minus infinity to plus infinity. What is it? Where x is between minus infinity to plus infinity. Okay, where x is between minus infinity to plus infinity. Okay, fine. So you please remember this, my dear. 1 by sigma root 2 pi e power minus half into x minus mu by sigma the whole square divided by nothing like that, and x is between minus infinity to plus infinity. Second point, what to remember, I'll tell you. It is actually what you know. the area to be found out. For example, if the area to be found out, okay. So this also what for like for reference purpose, you please remember it. For reference purpose, of course, you have to remember it. Yes. Now, the total area under the normal curve is equal to 1. I hope you remember it. Okay, total area under the normal curve is what? Under the normal curve is equal to 1. Okay, so this is what we have to do. So here, what is it? You know, it is nothing but integral of, okay, integral of minus infinity to plus infinity f of x dx is always equal to 1. Symbolically, this is what we are going to write. Okay, symbolically, this is the way we are going to write. Okay, or this also can be written as what, you know, integral of minus 1 to plus 1 f of z, sorry, minus infinity to plus infinity f of z dz. So symbolically, total area can be written like this: integral of minus infinity to plus infinity f of x dx is equal to 1. Integral of minus infinity to f of infinity f of z dz also equal to 1. So either random variable or normal variable, both are same, but the area is what? Equal to 1, my dear. The total area is equal to 1. Okay. Then for all x, f of x is always greater than or equal to 0. For all x, f of x is greater than or equal to 0. I hope you remember. Probability cannot be negative. Probability can be 0, but probability cannot be negative. So f of x should be what? Greater than or equal to 0 for all x. Okay, what is it? For all x. Okay, this you remember. Next, the third one. Point of inflection. What is point of inflection? You know, it is mu minus sigma, mu plus sigma. What is point of inflection? Is mu minus sigma and mu plus sigma. See, in this very important one point you need to remember, my dear, because generally this mistake people does. What is it? You know, this is what note under standard normal condition, under standard normal condition, point of inflection is under standard normal condition, point of inflection is always minus 1 comma plus 1. Under standard normal condition, point of inflection is what? Minus 1 comma plus 1. I will tell you the reason behind it. Why it is minus 1 comma plus 1? Because see, this is very important, my dear. Standard normal. In this standard normal condition, mu is always 0. Standard deviation is always 1. So in standard normal deviation, what is it? Standard normal condition, mu is always 0, sigma is equal to 1. Okay, mu is always 0, sigma is equal to 1. Therefore, our point of inflection is what? Minus 1 comma 1. What is our point of inflection? Is minus 1 comma 1. See, in the examination, the question can be asked like this, my dear. So what is point of inflection in the standard normal condition? What is point of inflection in the standard normal condition? Which is nothing. Okay. Yes. Fourth point to remember. Okay. Fourth point to remember. The relation between quartile deviation, mean deviation, and the standard deviation is equal to 10 is to 12 is to 15. Please remember this. What is the relation between QD is to MD is to SD is equal to 10 is to 12 is to 15. Sometimes the question can be asked, my dear, what is the relation between QD and MD? I hope you have seen it, right? So QD is equal to, I hope you have seen it, right, my dear? QD is equal to 6 by 5 MD. What is QD is equal to? 6 by 5 MD. What is QD is equal to? 6 by 5 MD. Or I think one famous MCQ you might have seen. QD is equal to, what is it? QD is equal to 3 by 2 times SD. Or standard deviation is equal to 2/3 of QD. Have you seen this before? Yes, of course, sir. I have seen it, sir. Actually, from here we can derive it. If you remember this, sometimes what happens, you know, instead of remembering everything, all the possibilities, you just remember this ratio. If the question is comes between MD and SD or QD and SD, Immediately what we can take QD and SD, right? So what I'll do now, QD is to SD is equal to 10 is to 15. That is, what is 10 is to 15 is? 10 is to 15 is what? 2 is to 3. So it is nothing but QD by SD is equal to 2 by 3. What is QD is equal to 2/3 of SD. What is QD is equal to 2/3 of SD. What is QD is equal to 2/3 of SD. Okay. Yes. Now, so if you remember this relation, then accordingly what we can develop so many relations, my dear. Okay. Now, sum number 5. Sorry, point number 5. Q1 is equal to mu minus 0.675 sigma. Please, my dear, sir, from where it came, sir, what exactly? Now, this is not the time for explaining these things. If you want to score 1 mark, yes, of course, for that you have to mug up this. See, I don't know how you maintained your notebook before. At least now, today, whatever I took now, at least that you can maintain a separate notebook and keep it as a last day revision. Please, my dear, when you write the exam, at that time, definitely you are going to thank me because, yes, of course, I've wrote it. So because of that, yes, I'm getting 1 or 2 marks. So please remember this. You write it. Q1 is equal to mu minus 0.675 sigma. Q3 is equal to mu plus 0.675 sigma. What is it? Q3 is equal to mu plus 0.675 sigma. Next point. QD is 0.675 sigma and MD is 0.8 sigma. See, from here only we derived this. This one only. Look at this. What is 3 by 2? See, what is it? QD is equal to 0.675 sigma. Na? See, QD is equal to 0.675 sigma. Is it 3 by 2? Sorry. This is actually 2 by 3. Right now. So now look at this. What we are getting 0.67 approximately sigma. This is what I'm writing. 0.675 sigma. MD is equal to 0.8 sigma. Okay. So please write this. And as far as this MCQs are concerned, from here only they will be asking, my dear, normal distribution. What exactly is the probability density function? It's a continuous distribution. It's a bell-shaped curve. It is symmetric. Okay, and the total area is my total area between minus infinity to plus infinity is what? 1. Okay, and the x is not random variable. Z is what? X minus mu by sigma. The area covered between mu minus 3 sigma to mu plus 3 sigma is 99.73%. Okay, next one is what the PDF is. P of x is equal to x e power 1 by sigma root 2 by e power minus half into x minus mu by sigma the whole square minus infinity. X is between minus infinity to plus infinity. Yes. Now listen here. Here parameters. I think I have not yet explained about parameters. For a binomial distribution, sorry, normal distribution, the parameters are mu and variance. Mu comma sigma square. What is parameter? Mu comma sigma square. So therefore, what is it, my dear? Biparametric. What is it? Biparametric. What exactly it is, my dear? Biparametric. Normal distribution is biparametric. The question can be asked in the MCQs. Sir, above, below the following, which one is uniparametric? Binomial distribution, normal distribution, Poisson distribution, none of these. Of course, it is normal distribution. Sorry. Of course, it is Poisson distribution. Uniparametric is what? Uniparametric. Poisson distribution is uniparametric. Okay. Yes. So, and last but not least, in normal distribution, mean is equal to median is equal to mode. Mean is equal to median is equal to mode. What is it, my dear? Mean is equal to median is equal to mode. Is it clear? Mean is equal to median is equal to mode. Yes. Please remember all the points, including the diagram, this one bell-shaped diagram. Okay, at least this much part, this much portion, I want you to write. Okay, I want you to write so that last day revision. Sir, I'm just literally, I want to leave this topic, sir. I don't want to prepare this topic, sir. Please don't do that, my dear. At least this much you write, at least this much you remember, at least this much you go and prepare in the last minute. Definitely, I'm telling you, my dear, 1 or 2 marks you can easily score. See, instead of getting, sir, leaving entire thing, getting 2 marks is fantastic only, na? So please believe me and do it. Okay. Now, Let us have a small differences. Okay, just let me just find out. Look at this: binomial distribution, Poisson distribution, normal distribution. Okay, first synopsis kind of thing. Binomial distribution. What is binomial distribution? Is a binomial trier or okay, whatever it is. Okay, binomial distribution is PMF, probability mass function. So this like, what is binomial distribution is? Binomial distribution is discrete, and Poisson distribution also discrete, and normal distribution is what, my dear? Also not the discrete, it is continuous. Correct? Yes. Now, in binomial distribution, we are using probability mass function, normal distribution, probability density function. Is that right? Next, what is probability mass function? What is probability mass function? So it is NCX P power X Q power N minus X. For binomial Poisson distribution, what is probability mass function? My dear? E power minus M power X by X factorial. What is probability density function? It is 1 by sigma root 2 pi. Okay, wait. Yes. Now, probability mass function and the probability density function. Okay. Next one is e power minus m power x divided by x factorial. And what is probability density function is 1 by sigma root 2 pi e power minus half into x minus mu divided by sigma the whole square, where x is between minus infinity to plus infinity. Okay. Next one. Fourth. Okay. It is biparametric. This is uniparametric. And it is biparametric. So, what are the parameters, my dear? So, it is uniparametric. And this is also again biparametric. Okay. So, what are the parameters? Here, n comma p are the parameters. What are the parameters? M is the parameter. And what are the parameters? Mu comma sigma square are the parameters. Okay. Mu comma sigma square are the parameters. Okay. Mu comma sigma square are the parameters. Fine. Now, see this one, binomial distribution. Binomial distribution can be symmetric, can be positively skewed, can be negatively skewed. Okay. Whereas Poisson distribution strictly positively skewed. Okay. Whereas normal distribution, it is symmetric, strictly symmetric. It is strictly symmetric. Okay. Next one. Sixth one. Here, what is it, my dear? Mean greater than variance. So in this case, mean is equal to variance. And here, what to remember? Mean is equal to median is equal to variance. This is normal distribution. Mean is equal to median is equal to variance. Mean is equal to median is equal to variance. Okay. Next is can be unimodal bimodal. Even Poisson distribution also what? Unimodal or bimodal. And this is what? Unimodal. It is rigidly defined because mean is equal to median is equal to mode. When mean is equal to median is equal to mode, you cannot have more than mode. It is a uniparameter. So it is unimodal. Normal. Okay. So at least this much difference you need to remember, my dear. It's a density function. So at least this much you need to remember. These are the basic differences, and all are basic MCQs. All are what? Basic MCQs. So without any hesitation, please write this, my dear. Please write this. So this will be definitely useful, my dear, in the last day of revision. Okay, last day of revision definitely is going to be much more useful notes than any other book, my dear. Okay, please write it down. So that's all with our theoretical distribution. The introduction part now got over. I think we can start doing the numericals now. Okay, we can start doing the numericals now. So before we start, can you please take your institute material and go through the questions on your own? I think most of the questions you'll be able to solve it on your own. Most of the questions now you will be able to solve it on your own, especially set TA and additional question bank theory questions. Okay, you can easily solve it on your own, my dear. Okay, fine. Yes. Now, let us start with the problems. I hope you have downloaded the material. Now come to theoretical distribution. Question number 1. A binomial distribution is never symmetrical, never positively skewed, never negatively skewed, symmetrical when p is equal to 0.5. Symmetrical when p is equal to 0.5. That is what our answer is. See, I think this is given to you. See, it is symmetrical when p is equal to q is equal to 0.5. It is symmetrical when p is equal to q is equal to 0.5. Okay. So first one, option D, my dear. Now, second question. The maximum value of the variance of a binomial distribution. I think this is also given to you. What is maximum value of the variance? It is nothing but n by 4. So that is option B. Second one is option B. Maximum value of the variance is what, my dear? N by 4. What is maximum value of the variance is n by 4, which is nothing but B. Okay. Third one. The total area of the normal curve. Sir, this is very simple, sir. The total area of the normal curve. See, what is the total area of the normal curve? Is nothing but, sir, 1, sir. Total area of the normal curve is what? 1. So total area of the normal curve is 1. What is total area of the normal curve is 1. So what is option? Option A. Sir, is this the way they are asking in the examination also, sir? Of course, my dear. This is the way they are asking in the examination. See, theoretical distribution, of course, when you do set C problem from institute material, you may be finding it very difficult. Sir, I didn't like theoretical distribution, numerical. Please keep those things aside, my dear. But in the examination, mostly these type of the questions they're asking. For example, if 6 to 7 questions are from this topic, 6 to 7 questions are from this topic, almost 2 to 3 questions are of this type only. Almost 2 to 3 there, this type only. So why should we leave it? Okay. Next step. Sum number 4. The sum number 4 to sum is keep on they're asking the examination. What is it? The interval u minus 3 sigma, mu minus 3 sigma to mu plus 3 sigma. Okay, covers. Of course, my dear, option A is 95% area of normal distribution. No. 96% area of normal distribution. No. 99% of no, because our answer is what? 99.73%. So what is the last option? All entire area, but 0.27% area of normal distribution. But 0.27% of normal distribution. That is full area, but 0.27% not covered. So our option is what, my dear? 0.27, sorry, 0.27, sorry, all but all but 0.27 percentage. Okay. Now fifth one. If the mean deviation of a normal variable is 16, what is the quartile deviation? If the mean deviation of a normal variable is 16, what is the quartile deviation? Guys, please don't leave this type of questions. Okay. Please don't leave this type of questions because I've already given you this thing like relation. What is mean deviation is equal to 0.8 sigma. Quartile deviation is equal to what? 0.675 sigma. See, among these two, now there is a common term, my dear. What is common here? The sigma is common between both, sir. What is it? Sigma is common between both, sir. So now what I will do, by using mean deviation condition, I'll find the value of sigma. That sigma, I'll put it in quartile deviation. I will get the answer. Now, what exactly I'm going to get? Sir, 0.8 sigma is equal to 16. So sigma is equal to 16 by 0.8, which is nothing but 20. Now, what is quartile deviation is equal to 0.675 sigma. So which is now I got the sigma value. So 0.675 into 20, which is nothing but 13.5. What is it, my dear? 13.5. What is it? 13.5. Okay, 13.5. Sir, the same problem also can be approached in different way, my dear. How? I'll tell you. I think I already given QD is to MD is to SD is equal to what? 10 is to 12 is to 15. Now, here we have to find out the relation between QD and MD. See, MD is given, QD they ask you to find out. So, I'll take only these two. What is QD by MD? 10 by 12, which is nothing but 5 by 6, right? So, can I say QD is equal to 5 by 6 times MD? What MD I got? 16. So, which is 80 by 16, sorry, 80 by 6. What is it, my dear? 80 by 6, which is approximately 13.33333 something we are getting, which is approximately 13.5. See, if you use this idea, still you are going to get the same answer only. Okay, if you use this idea, it is up to you. Whichever idea is possible, yes, please use it, my dear. Okay, yes. Sum number 6. If the mean deviation, sorry, sum number 6. If the point of inflection of a normal curve or 40 and 60 respectively, find the mean. It is not mean deviation, find the mean. See, what exactly given, you know? It is given as point of inflection, 40 and 60. That means mu minus sigma is 40. I told you, what is point of inflection? See, point of inflection is what? Point of inflection is that right? Mu minus sigma to mu plus sigma. So here, point of inflection is given as 40 and 60. So can we say mu minus sigma is 40 and mu plus sigma is 40? Now the question is, we need to find out the mean. What is mean here? Mu is mean. What is mean here? Mu is mean. So now can we add, sorry, this is 60. What is mean here? Mu is mean. Let me find out mean. Am I going to get 2 mu is equal to 100? So what is mu is equal to 50? They ask you to find out mean, my dear. Please write it down. Mean, they ask you to find out. So mu is equal to 50. What is mu is equal to 50? Yes. Come to sum number 7. Okay. For fitting to an observed frequency distribution, Poisson fitting, we equate Poisson parameter to the mean of the frequency distribution. Of course, my dear, look at this. Option A itself is the answer. Look at this. Poisson fitting. For Poisson fitting to an observed frequency distribution, we equate Poisson parameter with the mean. Now look at this. What is Poisson parameter? Sir, Poisson parameter is M, sir. This M is nothing but mean only. So we equate Poisson parameter with the mean. We equate Poisson parameter with the mean. Okay, we equate Poisson parameter with the mean. Okay, therefore our option is A. Our option is A. Question number 8. A binomial distribution is the same question only repeated, my dear. It is like first question. Binomial distribution is what? Symmetric when P is equal to 0.5. Option D. Ninth one. This is also repeated question only. The maximum value of the variance of binomial distribution with parameter n and p, n by 4. See, the repeated questions, of course, in the examination also repeatedly they are asking few questions. So I think in this lecture we are covering everything. Next, 10th one. Which one is uniparametric distribution? Which one is uniparametric distribution? Which one is uniparametric distribution? Binomial, Poisson, normal, hypergeometric. Let us not bother about hypergeometric and all. Binomial, Poisson, normal. Out of these three, which one is uniparametric? Binomial is biparametric, and normal is biparametric. Only Poisson distribution is uniparametric. Therefore, our option is B. 10th one, what is our option, my dear? B. Okay. Come to number 11. This one, what is it? The mean deviation about median of a standard normal variate. The mean deviation about median of a standard normal variate. Of course, my dear. See, mean deviation about mean deviation about median, mean deviation about mode, all are same only because mean is equal to mode. Sir, I know what is mean deviation about mean, sir. Mean deviation, I know, sir. It is 0.8 sigma, sir. What is it? 0.8 sigma, sir. This is what my answer, sir. If you do that, then it is wrong. Okay. You have to be very careful while reading the question. It is clearly given. What is given, you know? Standard normal variable. Standard normal variable, it is clearly given. When standard normal variable is given, I think I already told you, sigma is equal to what? 1. So therefore, what is actually mean deviation is 0.8 is the right answer. If you put 0.8 sigma, then you will lose your mark, my dear. Option C, if you mark, then definitely it's wrong. Option D is the right answer. What is the right answer? Option D is the right answer because it is, see, when you read the question, you should be very careful while reading the question. That is a standard normal variate. So in standard normal variate, sigma is equal to 1. So therefore, 0.8 sigma is nothing but what? 0.8 into 1. Our option is D. Okay. Yes. Sum number 12. If the points of inflection, I think this one is already done now. Okay. Next, sum number 13. What is the first quartile of X having the following probability density function? The probability density function is given as f of X is equal to root of 72 pi e power minus of x minus 10 the whole square by 72. Mostly what happens, you know, by looking at the question, people will decide, sir, this is very difficult, sir. Okay, by looking at the question, people will decide, sir, it is very difficult. This is not my cup of tea. I'm not going to do it. If you do so, then I cannot help my dear. Because that's a simple question. What exactly the question is? What is the first quartile? What is the question, my dear? First quartile. What is first quartile is? Q1 is equal to mu minus 0.675 sigma. This formula you need to remember. Correct? This is already given to you. Look at this. Q1 is mu minus 0.675 sigma. See, it is given. Correct, na? Mu Q1 is equal to mu minus 0.675 sigma. Fine. So that is the rule we need to use here also, my dear. Okay. So what I'm going to do, look at this. I have to identify what is mu and I need to find out what is 0.675, that is sigma. Then we can do it. See, just compare this with our original formula for a probability density function. What is it? It is 1 by sigma root 2 pi e power minus half into x minus mu by sigma the whole square. In the examination, no need to write anything. Okay, no need to write anything. Just do what I'm saying. Now look at this. This one. Okay, this is 72, right? This 72 can be written as 2 into 36. The 72 can be written as 2 into 36. Of course, my dear, this is the logic here. Look at this. The 2 I separated, 36 I have separated. Now, compare these two. Compare these two. In place of mu, we have got 10. So, mu is equal to 10. Correct? And in place of sigma square, we have got 36. So, therefore, what is sigma is equal to 6. What is sigma is equal to 6. Now, they ask you to find out Q1. What is Q1 is equal to? Q1 is mu minus 0.675 into 6. Mu minus 0.675 into 6. Just simplify and get the answer, my dear. I think the answer may be 5.95. What is the answer, maybe, my dear? 5.95. What is the answer? 5.95. Okay, Q1 is equal to 5.95. Q1 is equal to what? 5.95. Okay, yes. Next, sum number 14. Find the probability that at least 5 defective bolts will be found in a box of 200 bolts. It is known that 2% of such bolts are expected to be defective. Guys, it's such a lengthy sum, my dear. It will take time to solve also, because at least 4. At least 4 means what? Minimum, sorry, at least 5. At least 5 means what? Minimum 5. 5, 6, 7, it goes on like that. So, or otherwise, 1 minus less than 5. Okay, 1 minus less than 5. These are the two possibilities. Now, the question is, by looking at the question, I have decided, sir, this is Poisson distribution, sir. Okay, so what is M is equal to, sir? M is equal to, you don't need to find only, because in the bracket it is given e power minus 4. That means M value is 4, sir. M value is 4. But still, if you would like to find out, what we can do is N equal to 200 and P is equal to 2% is the defective. So therefore, what is M is equal to N into P. So 200 into 2 by 100, which is nothing but 4. So that is what our M value is. See, in this is the advantage, my dear. This is the advantage. In the examination, Poisson distribution problem comes, M can be directly taken, my dear. Okay. Yes, M can be directly taken, my dear. That is, the bracket it is given a e power. That is what our value of M. So what is our value of M is equal to 4. What is our value of M is equal to 4. So now here it is given at least 5. So X is more than or equal to 5. At least 5 means what? X is more than or equal to 5, which is nothing but 1 minus X is less than 5. It's opposite. 1 minus X is less than 5. That is 1 minus P of X is equal to 0 plus 1 plus 2 plus 3 plus 4. Okay, P of X is equal to 0, 1, 2, 3, 4. Okay, yes. What is it? 1 minus P of X is equal to 0. See, I think you know the formula for Poisson distribution. E power minus M, M power X divided by X factorial. Here what will come? E power minus 4, 4 power X by X factorial plus E power minus 4, 4 power 1 by 1 factorial plus E power minus 4, 4 power 2 by 2 factorial plus E power minus 4, 4 power 3 by 3 factorial plus E power minus 4, 4 power 4 by 4 factorial. See, I can listen to your mind voice, sir. In the examination, should I do like this at this big sum? Guys, it is up to you. Okay, it is up to you. Calculator. It is up to you. Okay, but I prefer not to do it, because if it is at least 5 and all, it will take a lot of time to solve. But still, here's the practice work, so I'm doing it. In the examination, just think twice before you take the call. Okay, yes, it is 1 minus, I can take e power minus 4 outside. It is 1 plus 4 plus 4 square is 16. 16 by 2 is 8 plus 4 cube is 64. It is 64 by 6. What is it? 32 by 3 I can write. 4 power 4. 64 fours are 256. 256 divided by 24. What is it? 256 divided by 24. 32 divided by 3 only again. 256 divided by 24. Okay, 256 divided by 24. Okay, 256 divided by 24. Yes. Yeah, 32 by 3. Okay. So both are one and the same. Now, which is, let me add everything. So 1 minus e power minus 4 is already given. 0. What is given? 0183. So what exactly it is? 5, 13. 13 plus 64 by 3. So 64 divided by 3 plus 13, which is nothing but 34.33333 into 0.0183 minus 1. I get 0.3717. Option B. What is our answer, my dear? 0.3717, which is option B. Okay. Of course, this will take a lot of time. The examination also, now the calculation will take more time, my dear. The calculation will take more time. 0.3717 is the right answer. Okay, that is option B. See, why it is taking a lot of time, Otherwise, it's a very simple sum. Why it is taking a lot of time, It is because at least 5. At least 5 means I have to take 0, 1, 2, 3, 4, all 4 to be taken. In the examination, once if you know how to identify this, that is more than enough. You no need to read the probability distribution, sorry, binomial distribution, entire question. Entire question also need not to be, there is no need to read it. Just if you can identify what is x value, directly we can write this step and we can complete it. How you know? Once you identified x value, then e power some value will be given to you there. That is what our m is. Then accordingly we can just add and we can complete the sum idea. Of course, yes, this one particular sum, it's what takes a lot of time. Okay. Yes. See, if this is the examination, for example, if this question was asked in the examination, and if I'm writing CA Foundation exam, I don't attend this question, at least at the beginning. I will ensure the other questions are solved, then only I'll come to this question, my dear. Okay. Next one. Sum number 15. Let x be the random variable with the following distribution. X is, what is given? -2, 4, 8. And the P of x is given 1 by 6, 1 by 3, 1 by 2. One by 6, 1 by 3, 1 by 2. Now what we need to find out? We need to find out expected value, which is summation x into P of x. Which is summation x into P of x. Okay. Yes. Sir, this is actually you said in binomial, in this our session, binomial or Poisson will not have x as negative values, but this one has got x as negative values. Sir, see, this is actually random variable sum. Okay, it is nothing to do with binomial or Poisson distribution. This is nothing to do with binomial or Poisson distribution. They ask you to find out expected value of x, which is summation x into P of x. You take your calculator, just do what I'm saying. 2, that is -2 into 1 by 6 m plus 4, that is what, like what, -2 by 6 m plus 4 by 3 m plus 8 by 2 is 4. 4 m plus MRC. Okay, what is it? 4 m plus MRC. I'm getting 5, my dear. Answer is over. See, what I did, nothing. -2 into 1 by 6 m plus 4 into 1 by 3 m plus calculator 8 into 1 by 2 m plus MRC. This is what our answer is. Okay, this is what our answer is. Is it clear? So this is what we have to do. Fine. Sum number 16. What is sum number 16 is? If x and y are two independent variables, so B of n1 comma p, binomial distribution n2 comma p. Now the question is, they ask you to find out, this is my x and y. So z is given as x plus y. So what exactly z you know? It is we have to add it. So binomial distribution, what will be our answer? I'll tell you. It is nothing but n1 plus n2 and common p. See, p is common now, so only one time p. This is what additive property of binomial distribution. What is this additive property of binomial distribution? Our answer is option A. What is our answer? Option A. Okay, our option is what? Answer A. Fine. Yes. Now listen here, my dear. See, at least this much. What we have to do is just copy the theory part. Copy the theory part, and every time, whenever you write any prelims or something also, whenever you write some preliminary exam also, what you can do is you just go through this. Okay, even during preliminary exam time also, you just go through it once and go and write the exam. Just go and write the exam. Definitely, what is going to happen, minimum 2 to 3 marks will increase in your actual scoring. Okay, so please just go through it every time, and after that, this one at least, this material, this theory part, you just go through. Okay, if at all, if you can go through the entire session, it is good, well and good. But we do not have time for watching the 3-hour session and all. These exams are nearing, so definitely 3 to 4 hours we cannot sit patiently and watch the lecture. So that is the reason we are uploading it on YouTube. Whenever you want to watch, at least a particular session, that half an hour session or 20-minute session, whenever you want to watch, that particular session you can watch, and you can just leave the leave the video and go and write the exam. See, it is up to you how you are going to prepare. So whatever JK Shah classes can be provided, more than what is needed is provided. Now it is your responsibility, it is your duty to do that, my dear. Now I think up to 16th sum I have completed. Up to 16th sum I have completed. Now the rest of the sums already what 3 o'clock now. Please go and prepare for your other examinations. So now we will meet tomorrow and we will continue with the other problems. And tomorrow I am going to take index number and time series. Tomorrow I am going to take index number and time series, and I'll be starting with logical reasoning also. I'll be starting with logical reasoning, index number, because once index number time series is over, the entire statistics also over. Mathematics except time value of money, that's all the topics got over. Now tomorrow index number and time series and logical reasoning we are going to start. Okay, logical reasoning we are going to start. I think in 1 or 2 days time we are going to complete the entire syllabus. I think 2 more days is needed, right? So yeah, 2 more days is needed. Yeah, in 2 more days I think we are going to cover everything, my friend. Okay, fine. So is it clear, all of you? So that's all with our session, today's session. Tomorrow I'm going to continue with sum number 7. And if you have any doubts, you can join at 3:30 for doubt solving session, my dear. I think the doubt solving session user ID password is already shared with you. You can join with me at 3:30. Okay. Thank you, all of you. Bye.